Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to be doing episode 5 of our Airbox series. Now, in the first couple episodes, we talked about QuickSurface LITE a little bit and how there are some different tools that can really help with this process. I'm not going to be going completely through the process in QuickSurface LITE because QuickSurface Pro is a much better option tool, and I'll talk about the differences, and we've talked about them before as well. But in this video specifically, what I'm going to do is I'm going to highlight some of the areas where QuickSurface LITE would help with the design. And also note, before we started this, I used QuickSurface LITE to align and to sort of prep the mesh before we brought it into Fusion. So I already did use it at the start, but I want to talk about some of the tools that we have for pulling data out and how those can be helpful. Now, what you see on the screen is just kind of what we're going to talk about. Primitive creation, so these are things like cylinders and cones that we can create pretty easily. Separating the mesh, processing the mesh, these are all the kinds of things that we can do. And just a quick note here, we are an affiliate for QuickSurface, so if you do want to purchase it or you're looking to purchase it, I'll just leave all that information in the description of the video. But just keep in mind that QuickSurface LITE is going to be limited. And what I mean by that is we do have access to things like 2D sketch creation. What we can do is we can extract curves directly from the mesh. So we do this in Fusion, but the tools are better in QuickSurface for this. We also have options to do things like auto freeform and create surfaces. So there are going to be limitations to these tools. For example, the QuickSurface LITE has a different algorithm than QuickSurface Pro. The Pro one is much better. We've talked about this in other videos. So if you want to learn more about the differences, we did a webinar for QuickSurface where we went through an entire part with QuickSurface LITE and Fusion and using QuickSurface LITE. Then we jumped to Pro and talked about the differences and kind of the benefits of those. So all that information's out there. I'm not going to do it in this video, but if you are curious as to kind of where those limitations are, you can leave a comment, ask a question, or check out some of those other videos. So what we're going to focus on is, again, going back to the original Airbox and also talking about some of the other tools that we have available to us in QuickSurface that can simplify some of this process. All right, so the first thing that I want to note is QuickSurface is a scanned-based reverse engineering program. QuickSurface LITE is a limited or pared down version of that. It still has things like alignment tools, extracting primitives, some surfacing and freeform tools, as well as manipulating the scan data. There are a lot of things that we can do in here with freeform, surface, and CAD models. Where we start to get limited are doing things like combining, cutting, intersecting multiple solid bodies. So if you remember when we did this in Fusion, we originally created 2 extrudes, and we use those 2 extrudes to keep the intersection between them. So we can generate those extrude bodies in QuickSurface LITE. We just can't combine them. That's just one of the limitations of the LITE version of this. You can do it in Pro, and there are also some other sort of automated tools in Pro that will do a few more cool tricks. But again, that's kind of why we're not going through the entire thing here, because we would still need to export it to another CAD program. So in terms of what we can do, so the first thing that we have is the original mesh was 2 million triangles, 2 million polygons. So the first thing that I would do is I'd go to scan data, and I would take a look at cleaning this up. Now there are some areas like inside where you can see there are some triangles that filled in holes. Likely what happened with this scan is when it was scanned, the processing of the scan had like auto fill holes or turn into a solid. So you can see there are areas where they were probably pretty tricky to scan, and they're just kind of filled in with these big blocks or blobs. Totally to be expected. I mean, that's kind of what happens if you end up with holes in the scan. It just kind of fills those areas in. But the first thing that I would do is reduce the polygons. So what's kind of cool is we can show the wireframe here. And if we zoom in, you can see how dense it is. And then we can preview it at different percentages. So if we say we want to reduce it to 50%, we can kind of see what that looks like. Now, the one that I provided in Fusion was all the way down to 5%. Now, you are going to lose some features. So when you do this, you do expect to have lower resolution in some areas. You'll notice in some areas it kept a higher resolution. we do end up losing things like that part number that was there. And there are other areas where we've got lower detail. So for example, this area here, we're going to lose a bit of detail. If we went back up to 50% and preview it again, you'll see that we end up with a lot more detail in some of these smaller areas. Now, whether or not you need that, that's kind of up to you. But generally, getting a smaller mesh, especially if you're going to be sending it to another program like Fusion, getting it as small as possible while still retaining the data that you need is going to be an important step. I'm going to keep original mesh, so it'll still keep that 2 million mesh in there. We'll say OK, and then now we've got the original, and then we've got a copy. One cool thing that I didn't show about this is we can also do an analysis. So you can see there's a deviation of the original mesh here. So when you have this option here, what you can do is you can say reduce the mesh count within a tolerance of this. We'll say apply, and you can kind of see, well, here's where we're deviating outside of that 0.01 millimeters. And that kind of gives us a good idea as to how close we are to the original. So I'm going to cancel this one, but just to kind of give you an idea. All right, the next thing that can be helpful is actually doing an edit on the scan. So when we bring this up, you can see there are 13 individual mesh bodies. There are 18 holes. We can also manipulate the boundaries. So when we see something like this and we say edit, if I click on this body, I've got the option to leave only the selected mesh, which will get rid of the other 12, or delete the selected submesh. Now, if we go and track next, it zooms in and we kind of can't really see what's going on here, but generally what happens is there are going to be a lot of tiny mesh bodies. So what we're going to do is we're going to select the big body that we want to keep. And you can see now it's left with just 2 individual meshes. So I'm going to say back. I'm going to come back in here, click this one, and say keep only that, and we're left with just 1 mesh. So that's the first thing I would do. Sometimes when you bring a mesh like this into Fusion or another CAD program, what ends up happening is those multiple meshes really get in the way when you start to play around with these. You can separate them in Fusion. There is an option to do that. So for example, in Fusion, you can separate meshes that are not connected. If they are connected, touching, overlapping, or something like that, it tends to have a bit more trouble. But it is somewhat possible in Fusion, but it's certainly not as easy to do. The next thing is if there are any open holes, what you can do is you can find those holes. Generally, these are going to be pretty tiny, so things like holes inside here. For this part, it's not really a big concern. I'm not too worried about those, but if you wanted to, you could fill all the holes if there were openings. This seems to have come out of a scan program and use the fill holes or watertight option, which is why we see things like this on the inside. Some of the other things that we can do that are helpful is this magic wand tool. If we select an area of the mesh and we start to increase this, you'll notice that we're able to select a large portion of the mesh. And you'll also see that it's excluding certain things. So this option is based on the angle between polygons. So you'll notice that all the rounded corners seem to be selected. There are some missing on the backside. If we start to increase it, it's going to gradually get more and more. But this is going to leave all of those sort of sharper corners deselected. And the reason that this is helpful is we can do things like copy and create. And so if we go back into our meshes, what we are left with here, we're left with basically a copy of the mesh that doesn't have all that other stuff in it. So you could spend a little time, make more selections, and then this would be easier for us to say, generate mesh sections. So for example, if I wanted to create a loft, I could do a little bit of work, try to fill some of these holes, clean up the mesh, remove features from the original or a copy of the original, and then I could create a set of curves like this that I could use to loft a 3D shape. Now, for this part, we've already seen in Fusion that it basically comes down to 2 extrudes and the intersection between those, so it really isn't needed for this type of part. But if we did have a part that had a lot more curvature to it, it wasn't quite as simple as taking a look at, basically these 2 simple shapes from the side, then I would totally go at it a little bit different and use things like the multiple sections option and creating something like a loft. Now for this part, again, because of the basic shape, you'll find that you can kind of boil it back down to some simple top, front, side views and generate the model. Okay, so that is, for the most part, the prep of the mesh. The other thing I do want to talk about in here is extracting primitives to align this to a coordinate system. So generally what I would do is I would pick or find a flat face. So this is fairly flat. I would create a plane. That's going to be used to align it. So we'll create and stay. The other thing that we might want is another plane if the side is flat. And let's go ahead and reduce this because I don't want it to roll around the corner. And let's do an analysis to see how close we are. So there's some high and low spots. These high and low spots are likely the result of the 5% or reduction to 5% of the original mesh. Higher density mesh would probably give us a slightly different result. But for our purposes, we're going to say create and stay. And so what this does, this gives me a planar reference. This one would be normal to the Z direction. It's already aligned in our case, but this would be normal to the Z direction. This one would help us represent the XZ plane. And then if we needed another sort of reference, we could do the same thing up front. So again, using this tool, maybe increase this until I've got more data. If we want to, we can select more, create a plane. You can see the Toyota logo, even though we have a reduced count, is still there. And then we'll select create. So now that we have those three, we can do an alignment by coordinate system. And what we can do here is pick the primary reference. So I'm gonna have to go all the way down the last three planes I created. So plane 10, I'm gonna flip this so Z is pointing up. My secondary feature is gonna be plane 11. So that's gonna help us determine the XY orientation. And if I need another reference, we can use plane 12. And you can see what it did was it put the coordinate system at the intersection of all three of those. Now, if you want to, if you use things like a cylinder or other references, if you create a point reference, an intersection between two lines, then you can actually pick where that goes. So typically on cylindrical parts, you might put that at the center. For our purposes here, for this design, that works okay. We could also manually translate it or move it to another position if we want, but I think that this works okay. So we're going to do apply on all imported CAD and all features. So this will essentially take everything that's in this design right now, apply it, and close it. All right. So if we bring back some of the other features that have already been created, you'll notice that they moved as well. So you can kind of see that they're there. All right. So that is basically the prep portion. So what I mean by that is cleaning up the mesh, removing extra details if we need to, extracting some primitives mainly for the purpose of alignment, and getting it aligned to a coordinate system. So that's the first step in this process. Whether it's going to go to another CAD program or if it's going to stay in, let's say, QuickSurface Pro, then I would still do all of those steps. Now, the next area where QuickSurface LITE is a benefit to this is the extraction of primitive features. Now, this isn't going to work for everything, but we do have the ability to pull out basic features, things like cylinders and cones. Since this is a drafted part, all of these features are going to have draft on them, so they would technically be cones, not going all the way to a point. But this can speed up the process where we don't have to create a plane, we don't have to create a sketch, we don't have to go through and then extrude that and then combine everything together. What we can do is say extract primitives. I'm going to go ahead and pull this to the side a little bit, and let's just grab this. All right, so again, I'm using that magic wand tool. The drag strength is going to determine the number of triangles, and we can say, let's go ahead and, for this one, I'm just going to say cylinder so we can see. All right, so it's going to generate a cylinder. We also can turn on analysis to see how close we are. Now, if we don't like that, we can clear it and say, well, let's create a cone, and we can see if the cone is closer. Now, you can see the cone is way off, so we're going to clear it, but if we take a look at how much we have selected, so we may find that we want to go back and hold down Shift and maybe select more specific areas and try the cone again. And you can see the cone in this case just isn't working. So what I would do is create a cylinder. It seems to be pretty close for our purposes. Create and stay. Now for some of these other features, again, we'll do a little bit of a selection. It's going to be based, hold down Shift and select more. It's going to be based on the triangle. So come around the other side a bit, let's say over here. And let's try to do a cone there. All right, so cone is definitely closer for this one. You can see the color bar here. And what I'm going to do is I'm going to say create and close. And I'm going to bring back the high res mesh. And the reason for this is what you'll find is a lot of times with the higher resolution mesh, you'll get a better result. All right, so let's turn on the analysis. Let's try a cylinder here. You can see the cylinder is much closer. Now, some of this is bulged out, again, probably from the scan. It kind of filled in some of these areas. So it has to work with the data that it has. We're going to say create and stay. If I select over here and start to increase this, you'll notice how it's coming down inside of those ribs. I'm going to hold down shift and select more, and maybe over here, and try a cylinder there. You can see the cylinder is much closer in this case because of how it was scanned. Create and stay. I'll grab over here, try a cone. I'm sorry, not cylinder, cone. You can see this one's off, so we'll clear it. Take a look at the selection. In this case, probably a cylinder is going to be closer. We'll create and stay. This one up here, shift select the other side, create a cylinder. Looks pretty close, create and stay. I want to do the inside as well because we're going to have to remove material from the inside. The inside of this one's a bit messy, so that would be a little bit trickier. But again, we would just kind of work our way around, picking up on all these features, and then quickly creating these. All right, so I'm going to zoom in over here, create and stay. On the inside of this, we'll create a cylinder, create and stay, kind of work around, and do this one as well. All right, and we'll say create. So with all of these, this is, let me bring it back up here. This is, again, a quicker way that we can generate these shapes. Some of them might be off, like this one, we might need to go back and create it without the taper. But on these larger ones, all we really need to do is just extend them out. So like this, we'll just extend out until it fits goes into the body there. We'll do this one. And then if we're to export this, so if we were to send this to Fusion, for example, then all of these would come in as solid bodies. We could join them together there, and then we could shell. So like the inside one we might not need if we're going to shell it, so I'll delete that one. But what we could do is we could take all of these, and all of these would be part of an export, and then in whatever CAD software we use, we could just combine them all together. So if you're using something like QuickSurface LITE, you're likely not going to be able to recreate the entire Airbox in there just because of the limitations of the CAD tools. You won't be able to do any of these Boolean operations like combining, cutting, or intersecting. You will have limited access to certain tools. So for example, if we do a 2D sketch, and let's extrapolate a sketch from, let's say right there, and we create. So with this sketch, we do have the option to extract primitives. So for example, we could come in here and we could pull out a line. We can come down here and let's pull out a line there. And then we could pull one out there. We could also do fit arcs. We could basically work back and generate these curves and build out these solid bodies. But we are going to have limited access to certain tools. So for example, this corner trim tool, some of the automatic options are only going to be available when we're working in Pro. Some of the other options that we have that allow us to, basically extend these together, they do work in here. And so like we could change the constraints here to tangent. But then you can kind of see that things are starting to get away from the sketch. So when you have Pro, there are options for some of these automatic tools to generate curves for you, which really help. There are also some quick tools that you can use to extract some of this data. And then you could use this for things like extrudes and revolves and so on. You can still build all that geometry here. You just don't have the ability to combine them together. There are also limitations on things like fillets and chamfers. So for my purposes, what I would say for QuickSurface LITE user is the main function here is mesh processing, mesh prep, extracting primitives for alignment. And then if you want to speed up the workflow a bit, you can also export or generate primitives like these cylinders. You can export all the CAD data. All right, so we can export the model, which will send all the CAD data out. And then we can also export the scan data. And the benefit here is that when we export the model, and sorry, I just upgraded this computer to Windows 11, so nothing is where it should be. I'll just go I'll save it in Fusion. And we'll save it as a step. And then if I go here and say export scan data, actually, you know what? Let's do this. I want to export just this one. So I don't want to take all the meshes. We're going to go here, Fusion, and we'll send that as an STL. So with all that data exported, if we go back into Fusion, what we can do is I'm going to open. Again, it's going to be in the wrong place. Let's go to Fusion, Inbox, and we want, where the heck is it? Oh, sorry. Again, it's mapping it to SolidWorks. All right, and then we're going to go to Mesh, Insert, same place, Airbox, STL, and we'll say OK. And you can see that the mesh is aligned to the same coordinate system as all of the solid bodies. So it's a good starting point, even if you are going to do the majority of the modeling directly here in Fusion. You'll also notice that the solid bodies it brought over are only the solid bodies that were visible at the time. There were a lot more other bodies that had already been created in that file, but these are the only ones that are visible. So that's a nice thing that we can do, is just show the ones we want to export. But now we've got the mesh and all these solid bodies, so you could continue to do standard workflow like, let's say, combine. Actually, you know what? That's not going to work, because with the step export, all of these are unstitched surfaces in their own file. All right, and I talked about this before. The quick fix for this is to turn off history. So we're going to go to direct modeling, and then under the inspect tools, we've got this validate. And essentially what we could do is, let's see if I can select the entire design. I don't think that's going to work. Let's just box select this stuff and click repair. And we'll say OK. It's not going to work because it's only grabbing the visible ones. All right. Inspect, validate. So each of these surfaces is its own component. I've mentioned this before, but I should have exported an IGES file and not a step file. And then we'll say OK. Crap. All right, let's go back to QuickSurface. Let's go to export model, and let's save it as an IGES file. All right, so in Fusion, so essentially if you're saving out an IGES file versus a step file, so a step file puts everything as individual components, whereas the IGES file is putting it all in one component. So the IGES file is definitely preferred, at least in this case. You'll notice that it's all coming in as unstitched surfaces. So what we're going to do is right click and change to direct modeling, which opens up this validate tool. And then the validate bodies, what we're going to do is select everything. I don't know if this is going to work because there are a bunch of individuals. Refit bad surfaces, small edge face removal, gap healing, repair. We'll say OK. And now we've got solid bodies. So then we can go to mesh, insert mesh, and we'll pick the Airbox, and it should come into the same coordinate system. So if we go back to our solid tools, we can combine all these things together that are overlapping, for example. So let's say this one as well. And then once you get further in the design, of course, you can shell these just like you would the regular part. And then you've got, your Airbox here. Now keep in mind, you do likely want to go back to parametric modeling after you use that repair tool. That you don't have to use the repair tool. It's just a bit quicker than manually editing and stitching all those surfaces together. But the main takeaway there is that QuickSurface LITE has a lot of features that can be helpful, mainly in the mesh processing, extracting primitives, and alignment. You can still generate solid models with traditional means like extracting sketches and doing extrudes. To me, that is actually, at least on this model, is a little less helpful, just simply because you still have to do that in Fusion or whatever CAD program you want to use anyways. So it doesn't have as much benefit to me as, say, extracting these primitives, because these prevent us from creating a bunch of extra planes and then having to generate those models, especially if you're trying to redo this part for 3D printing as opposed to injection molding. This can be a really quick way to get something that is close. And in QuickSurface LITE, you still have those analysis tools. So when we do things like extract a primitive for this, and we generate a cylinder, we can turn on the analysis and we can see. Now, once again, even though we have it set to create a solid, when we create this and we export it, that IGES model ends up being untrimmed or unstitched surfaces. So in Fusion, we just use the validate tool, which can kind of fix those things quickly. All right, so that is the extent of it. I have had a few requests to do this in QuickSurface Pro. If people want to see that, we can talk about that. The process is going to be kind of a mix of what we did in Fusion and what you saw here, where we're going to use curves and sketches to create extrusions and kind of keep the intersection or the overlap between those for that original shape. And then also we have the ability to do all of these primitives. There are some quick ways that we can do this with auto freeform. If you're just trying to get a really quick result, you can use auto freeform in Pro, which again is much better. You can see the one here in LITE is failing. It just doesn't have the algorithm to handle this for the entire mesh body. You could do it on smaller sections like this. For example, you can do a fit surface, and it's probably not going to do well, but I'm just going to click it anyways. So you can see a fit surface gets us pretty close. What I'm going to do is clear that. I'm going to reduce the triangle count, and actually, you know what? Let's use this tool. So let's say that I wanted to generate a surface that fit over here before the fillet. Let's go ahead and just paint all this. Because everything's smooth, the magic brush doesn't work as well. And then we can create a fit surface that's over there. We can do the same thing on some of these sort of planar regions. We can create more flat surfaces and kind of do it over here as well. And then on bigger surfaces, like this is fairly flat over here, generate one there, generate one on that face. And basically what we have now is we've got these surfaces that we can extend and use as trims and overlaps and basically build out a solid body that way. Again, there are limitations to QuickSurface LITE. You could build all these surfaces, but you are going to have some limitations in the trim. So for example, I'm going to select these, select both of those. You can see here the trim feature is in Pro. Now the trim feature is super powerful, where you can select a ton of surfaces and then kind of trim away anything that overlaps and build out a solid body pretty quickly. But again, it's one of those things where we can generate some of these surfaces and export them to Fusion, but then we still need to do some work there and do some trimming and so on. All right, so that was a long video, a lot longer than I anticipated, but hopefully that helps understand where QuickSurface LITE can fit into this. Again, I think that it has a definite place in preparing the mesh and aligning and generating some of these primitives. In terms of trying to model something like this with QuickSurface LITE, you're just not going to be able to do it just because of the limitations of the LITE features with things like the combines and the trims and the fillets and chamfers and things like that. So you will still need some CAD application, whether it's Fusion, whether it's Plasticity or SolidWorks or Inventor or whatever, then you will still need another piece of software in your in your lineup to make that happen. So any questions on this, please let me know. As always, thanks for watching, and we'll see you in the next one.